Thank you, Liska. Thank you all for joining. This webinar is all about building microservices. So I'd like to start by sharing some general considerations about microservices. And from there on, I'll explain you more about the agenda for the rest of this webinar and the fun stuff that we're going to do. Microservices in general is this idea, if you would look at it as a diagram. Instead of having the big single monolithic system on the left, you split that system up into several independent parts, and some of them can actually run multiple times in parallel to get some scalability. That's the purple one, exemplifying that. So the idea here is that you get two things out of this in general, two reasons why you would do microservices. One is to have an enhanced version of agility, so you can evolve individual microservices more easily because they're smaller, and you can bring new versions into production, so you can get a new functionality out there a lot quicker than you could with very big monoliths. The other driver for microservices is scalability. So when you have small microservices and you make them stateless and have some other conditions on them, then you can potentially have many of them running in parallel, and then you can process higher loads. So in general, these agility and scalability concerns are what's driving these microservices initiatives. Of course, those benefits don't come for free. What you have to pay is dealing with additional complexity. Having a microservices system and making everything work together and dealing with the APIs and everything, that's inherently more complex than dealing with a single monolith. So the question is, of course, how is this going to work out? Now, what you want, of course, is this. So you want the big benefits of agility and scalability, and if you properly design your microservices system, then the additional complexity would be easily managed. So this is the situation that we're shooting for. But in reality, many microservices initiatives end up in this situation. Very little additional benefits of agility and scalability. We see, for instance, situations where an initiative is based on microservices, but they have to be all deployed at the same time. So what that situation is most appropriately described as a distributed monolith. With a distributed monolith, you do have to pay the price of the additional complexity of microservices, but you don't really benefit from those agility and scalability benefits that microservices systems should have. Big question is, of course, how do you make sure that you end up in the right situation with agility and scalability benefits outweighing those potential negatives? Well, we believe that first of all, it's important that you cut the right boundaries between microservices. If you have the boundaries right, then microservices are autonomous, and because you're autonomous, you can deploy them individually, you can scale them individually. That's really a cornerstone of getting those benefits in. Second thing, it's important to start developing a monolith and then evolve towards microservices rather than starting a microservices initiative from day one. Projects that start out as a microservices project tend to focus very strongly on technical aspects, on getting all the integration right, on doing all hipster stuff with circuit breakers and Kubernetes and what have you. And all of this is at the detriment of actually developing business value, of understanding the domain, and getting your system right to begin with. So in general, to get this right, start developing a monolith, but do that in such a way that you can easily evolve towards microservices once you hit the point where this makes sense. This is exactly what we want to support with Axon. We do it in two ways. Looking at how we ensure that you cut the right boundaries, we implement three concepts: CQRS, event sourcing, and DDD. Looking at the part of evolving towards microservices, we implement a concept called location transparency. Those are the cornerstones of how Axon enables creating the right microservices systems that will give you those benefits. So this is also what I want to cover in the rest of this webinar. So first I'm going to talk about those concepts and explain how exactly CQRS, event sourcing, and DDD help you create those microservices systems. That will take about half of my speaking time. Afterwards, I'm going to do live coding and show you how to actually do this in an Axon application that I create from scratch. I will start out as a monolith and then evolve it towards a microservices system. And the beauty about Axon is that we can actually do that within about 40 minutes from now or so. So starting with those concepts. First thing, CQRS, Command Query Responsibility Segregation. To understand the concept, it's easiest to start with a non-CQRS situation, and we contrasted it from that. So here we see a very generic model of what any kind of application could look like. You have part of the application called the domain model or the business layer or whatever it's called that actually contains the logic that you're implementing. And then there's some interface in front of that that's interacting with that domain and exposes it to your user. So that might be a graphical interface or a SOAP interface or a REST interface, doesn't really matter a lot. So from that interface, there's all kinds of interaction, requests with the domain model, and those requests in general may do a bunch of different things. So they might be an instruction to change something, to register a new user, or to add some money to a bank account or anything. It also might be an inquiry for information, or they might somehow combine these things. Now, what you see in this case, in general, is that these data models tend to be optimized for writing. So if we all know that if you create a relational database schema, you don't want redundancy, you do want foreign key constraints, you do want normalization. That's all intended to optimize for writing and to make sure that nothing can go wrong there. Now, if you look at the interaction from users with the query side, with just getting data from the model and not changing anything, that means that typically you have to combine data from many different tables or objects. So these queries tend to be quite complex. And if you use SQL, then you would see many joins there. If you do have such complex queries, you get two different problems. So one is that these queries become expensive to execute. And the second problem is that these queries are very hard to maintain. And the expense of execution is actually a quite severe problem, because in most situations, queries are much more common than writes to a model. And we have really optimized for writing. So we do have some challenge there in typical systems that will reduce their scalability and performance. So CQRS offers an improvement on the situation based on two core ideas. So the first idea is that you could potentially simplify queries if you would store a copy of the data in a form that's very easily queryable. So you just have to select the right record and then return it. That's not a very new idea. In database terms, that's called a materialized view. In CQRS terms, that's called a read model or a projection. But fundamentally, that's the same idea. CQRS adds another idea to that, and that's the observation that in many cases, the updates to these query models doesn't have to happen in the same transaction as processing the actual command that triggers that update. So you can have some eventual consistency there. For example, if I withdraw money from an ATM from my bank account, and of course if I later log into to my online banking system, I do want to see that this withdrawal has taken place. But if that happens a couple of milliseconds later than the actual withdrawal from the money, that's totally fine. I don't expect that to be immediately consistent. A little delay is totally acceptable, and that's the case in many situations for many read models. So with CQRS, our architecture looks like this. Instead of one big cloud, we have two clouds. So one is the command model, other the projections, so read side. Client sends commands to the command model and queries to the projections. Now, of course, for this to work, the projections need to be kept up to date with what happens at the command side, and that's where events fit in. So whenever the command side approves of a command, it will publish an event. The event will be picked up by the projection. Projection updates its internal state so that next time the client asks a query, it will get the right answers. That's the basic architecture. Now here we see immediately how this helps us to do microservices. On the pink lines delineate potential boundaries between microservices, and of course in this case, especially if I use eventual consistency, the command side and the projection side could be totally separate services linked together through some kind of event bus that allows the command model to publish those events and the projection side to read them. So this very naturally fits in a microservices architecture. But there's more than that. If we zoom into the projection side, thinking about how we can best create them, then these projections are always optimized for a very specific read use case. That's what's keeping those queries really simple and fast. So you would have one big projection. You would have many separated ones, each having their own optimized read model. Also, they may very well use optimized technologies for a particular type of query. For some types of queries, if you want to return very structured data, a relational database might be the best choice. But if you want to have a query model that supports full text search, you probably would use Elastic. If you have very big documents with lots of semi-structured data that you want to return at once based on a single request, Mongo might be a great choice. If you have graph-based queries, probably you would have a read model based on Neo4j. So you have many different options there, and one of the beautiful benefits of CQRS is that it allows you to combine this in a very structured way. From the microservices perspective, this means that it's not just the entire projection side that can be a separate microservices from the command model, but you can split the individual projections each into its own autonomous microservice if that's what you want. You don't need to do that with Axon. We support microservices. We support evolving towards that. But it's important to note that you potentially can. Now let's have a look at the command side, and we'll do that by looking at the DDD, domain-driven design concept of aggregates. Domain-driven design is a huge topic. You could talk for days about this alone, and we're not going to do that in this webinar, of course. Domain-driven design has a couple of strategic concepts. It has a couple of very specific tactical building blocks. Honestly, all of this stuff is very, very relevant to creating complex Axon microservices systems. So it's a great topic to study. The classic books are by Eric Evans and by Von Vernon. It's very great stuff to learn more about if you want to. For now, I want to focus on one specific aspect of this that's relevant to our microservices discussion, which is the aggregates, one of the building blocks of domain-driven design. Again, I'm going to contrast with a non-DDD and non-aggregate situation. I just Googled some random entity relationship diagram, which is typical of systems not built according to this principle. And what you see here is many different tables, and these are all related to one another, and most of these relationships would be implemented as foreign key constraints. And the text that came with this picture actually said that some of these diagrams contain hundreds or even thousands of tables all related. This will never ever become a microservices system. Forget about it. This is not going to work. You need to do something very different. That's where aggregates come in. So if you design your system in aggregates instead of creating this big connect ERD, first of all, you start thinking about your domain model as you would represent it in your code and not so much in your data structure. Code is the starting point. You are not connecting everything to everything. Also, you're not creating Java classes with just getters and setters. But instead, what you're designing is these things called aggregates. Aggregates are graphs consisting of one or maybe a few objects connected together that are considered a unit from a perspective of persistence and consistency. So when you save them, you save conceptually the entire aggregate, or you read the entire aggregate, and the aggregate itself is responsible for its own consistency, for its own business rules. So it wouldn't change its state without verifying that it would actually end up in a valid state afterwards. Aggregates do not have direct access to other aggregates. That would make it one big aggregate, and you want to keep it separated. So in order to function, aggregates usually contain copies of data that's also in other aggregates. They may refer to other aggregates, but only indirectly, not through our database link, but they may contain a copy of an identifier of another aggregate if that's useful. To make this idea a little bit more concrete, I have here shown a couple of aggregates that you could have in an e-commerce system. So in any kind of e-commerce system, you would have orders, you would have customers, and you would have products. If you would go with this old ERD approach, that would all be connected, because orders obviously always refer to a customer, and order lines always refer to some product. That would immediately create some interesting challenges. For instance, what if the price of a product changes? and the product is on orders that have already been paid and delivered. And obviously, the total price of that order shouldn't change just because the product got a new price in the store. With the aggregate approach, you would have these objects much more independent of one another, and you would actually copy data. So once the product gets added to an order or to an order line, you would copy the product name and the unit price of the product aggregate to the order aggregate. And then later on, if the product changes its price, that wouldn't influence existing orders at all. So that's the notion of aggregates. Linking it back to microservices. Of course, again, because these things are so independent and have a consistency boundary and don't assume that you can do transactions across them, you can very well deploy them as separate microservices if you wanted to. So if we now combine the divisions that we already had with the new one of aggregates, we see that the concepts of DDD aggregates and CQRS give some great ideas on how we can structure our monolith in such a way that we can easily split it into microservices if we wanted it to. Each projection can be its own microservice, and each aggregate can be its own microservice, and they would exchange events, commands, and queries with one another. Now I'm going to switch to the third concept I wanted to cover, which is event sourcing. Event sourcing is a strategy of storing aggregates. And the regular way of storing aggregates or entities would be to persist their state in a database using CRUD semantics. So you can insert new ones, create new objects, read them, update them, delete them. And usually in Java, people do that using some kind of ORM framework like JPA, Hibernate, or something similar. With event sourcing, you do something totally different. Instead of storing the current state and updating that, you store a history of everything that happened, all events that have taken place for an aggregate. And then if you need the current state, which you would generally need to do your business logic, you couldn't read that directly from the database. It's not there. You would have to read the events and then calculate the current state based on the history that you have. That's the event sourcing idea. And the first time people get exposed to this idea, usually they find that weird and inefficient, and general response is, why would you do that? Now to get some understanding for that, the easiest is to think about bank accounts. Suppose that you have a system that's managing bank accounts, then the regular way of storing these, so the CRUD way, would be to have the bank account and its balance in your database, and then whenever some payment or transaction takes place, you would actually update the balance. You would overwrite the previous value in that act. And then if someone wanted to know what actually happened to the bank account, what transactions had taken place, that really wouldn't be in the database because you would be overwriting that all the time. So you would have to probably look into the log files of the system, hoping that they would have logged the transactions. If you would store a bank account using event sourcing, you would do something different. You would say, well, whenever a payment transaction takes place, I'm going to store the details of that transaction as an event that has taken place. And then if I want to know the balance of that account, I can actually easily calculate it from the transactions that have taken place by simply adding them. And then I have it as a derived value. Now, of course, with bank accounts, that is the actual way that bank account systems are being designed. That's the only reasonable way of doing it. The transaction information is way too important to override and just keep in some obscure log files. That's a key thing to record. So with bank accounts, event sourcing is the normal way of doing it. Event sourcing in general as a concept is essentially treating any aggregate that you have like a bank account, so storing the events rather than the outcome, even when it's not a bank account, but something totally different. So why would you do that? First of all, there's great business value there. And I've actually copied a tweet here from one of our users from Barclaycard that has perfectly illustrated one of the benefits of event sourcing. It really helps you with auditing and compliance. You have all the events stored, so auditors become really happy if they need that data. The other business reason is that you can actually learn from data. If you know very precisely what has happened in the past in your business, you can do data mining, analytics, machine learning. You can make reasonable predictions for what's going to happen. You can optimize your business processes. In general, there's great value in data. And with event sourcing, you don't throw data away. That's the key logic here. In addition to the business reasons, there are some great more modeling, architecture reasons. Generally, it's easy to write, to implement business processes in this way. You can do things like capturing intent. And there are a couple of more technical reasons. If you really want to be sure that you are raising all the events that can occur in your system, and with a non-event sort system, you would always have some uncertainty because creating the event would be a programming action separate from actually making the changes to your primary storage. With event sourcing, that kind of discrepancy cannot take place because storing the event and publishing the event is the exact same thing. So there are many reasons to do event sourcing. Looking at event sourcing in combination with CQRS, they are conceptually and technically independent things, and you can do one without the other, but they are great together, and they're very often used together and often mentioned together for that reason. If you assume event sourcing, then why would you do CQRS? Well, first of all, because without CQRS, it would be very hard to read data from your event store. So with an event-sourced architecture, you can read individual aggregates quite efficiently. But suppose you have a large system with bank accounts and you want to pick out all bank accounts with a balance of more than 1,000, then there's no efficient way of doing that directly on the event store without actually reading all the events and doing all the calculations. So to make arbitrary efficient queries possible with event sourcing, you're kind of forced to do CQRS. In the other direction, if you want to do CQRS and you do have those projections, then it's not only about keeping those projections up to date in a running system, it's also about introducing new projections in the system that's already in production. Once you do that, you're going to have to find a way to initialize those projections, and by far the easiest way is to replay all events that have already taken place. But then of course you need to have them stored somewhere, and event sourcing will guarantee that you do have those stored. So CQRS and event sourcing are really a great combination, often used together. Stepping away from the concepts, let's have a look at how these are actually implemented in Axon. I'm not going to have a lot of slides about Axon, actually just one before I go to the live coding part. Looking at Axon, the Axon Platform, it's actually the combination of two things. So one part of Axon is the Axon Framework, and the other part of Axon is the Axon Server. The Axon Framework is a Java library or a set of Java libraries. So you would build them into your application code as a Maven dependency, typically, next to a bunch of other dependencies that you would likely have. It's fully open source, Apache 2. It implements these ideas of DDD, CQRS, and event sourcing, and it doesn't make a lot of assumptions on what kind of infrastructure you're running. So you can run it with all kinds of different bus technology and database technology. It abstracts that away. Looking at Axon Server, the other side, Axon Server is a built-for-purpose event store and messaging platform for commands, events, and queries. It makes it very, very easy to write a scalable Axon Server application and really implement a microservices landscape. So that's what I'm going to do in the demo as well. It's open core, so we have a free open version as well as a commercial version. With Axon Framework, it's highly recommended for new Axon applications, but technically it is optional. If you want to use Axon Framework but not Axon Server, that is possible still. So I'm going to very shortly switch to live coding. Let me quickly introduce the domain that I'm going to show you. It's about gift cards. So we've chosen gift cards as a demo domain because it's quite a simple domain. Gift cards conceptually get issued, and once they get issued, they have a certain value for which they can be spent. And so whenever they are being used by the receiver of the gift card to buy something, or when they're redeemed, as the language is, then this remaining value is adjusted. Of course, the value of the object that has been bought would be subtracted from the remaining value, and you cannot spend more than the value that is on the gift card. So that's a very simple domain, and let's see how we can implement it with Axon Framework and then split it to Microservices System afterwards. Oh, yeah, before I do that, of course, I've shown you the download page a couple of times. It was actually in the footer of all my slides. I will also publish the code that I'm going to write now to my GitHub repository on this URL, which will also be in the follow-up email. So I'm going to show you the download page. There we go. So here on this download page, you can download the Axon Quick Start, which has the server and the framework and a sample application and a guide. So it's a nice download. We do have some other ones as well. We have Docker Hub coordinates of our Axon Server. You can download Axon Server as a zip file. And we have the Maven coordinates of the framework here as well. So there's everything to get you started. Let me begin by booting up Axon Server. I'm going to use that Docker code that we had there. So the sample runs as a daemon. I actually prefer to run that interactively. Let me start that. So there it goes. That's Axon Server starting. I'm going to create a new project. I'm going to use Spring Initializer. Spring Boot and Axon is a great combination. It's not the only way that you can write Axon applications, but it is a great choice for new microservices. I'm going to make this the gift card project. Let's be a little bit more optimistic about the versioning. And that's a demo project for Axon. So I'm going to choose some dependencies. With the style of programming, you need a lot of value objects. So Lombok is a great choice. I'm going to choose a technology to store my read models as well. And you can choose anything. Here I'm going to choose JPA in combination with Postgres. So that looks fine. Meanwhile, since I'm going to use Postgres, let me fire up a Postgres database as well. So I'm not going to run Axon Server, but I'm going to run a Postgres database. So the Postgres port by default is 5432. So let me expose that here as well. That's going to be a Postgres, say 96. I'm going to need that image to create an initial database. Let's call that the gift card user and database and make that with a super safe password secret. So that should give me a Postgres database to use. Great, so my infrastructure is all set now. Back to IntelliJ. First of course, I need to add Axon Framework here. I can pull that from the download page. Here's the Spring Boot starter. Let's just put that there. So now we have Axon. Let's do some housekeeping. I'm not going to test anything. I'm just going to write correct code. So just for simplicity, I'm going to throw this away. Let's set some properties straight. It's always good to have the Spring application name there. It's called gift card for now. Let's enable some logging. That will help me explain some of the concepts. Let's connect to that Postgres database. So the password was secret. The username was gift card, and I need to tell it where it is, of course. So that was on my local hosts, and the database is called gift card as well. So this is my Postgres setup. I'm going to ask Hibernate to initialize the schema. And let's also tell Axon where the Axon server lives. So this is actually the default, so I could have left it away, but it's nicer to do that explicitly, I think. So now we are set up. We have our properties rights, so we're connected to the infrastructure. Let's do some coding. I'm going to create a separate package for my command side. Makes a lot of sense, of course, in a CQRS architecture. And let's make a distinction between the API of my model, which are the commands and events, versus the implementation, which is the actual aggregate. So let's create separate packages for that. Now at my command side, I'm going to need to implement that issue command and redeem command, as well as the corresponding events. So let's start with the issue command. I'm going to make this a value object. I need to have the identifier. I use UUIDs for my gift cards. It's a common choice with Axon. And I'm going to need to store the amount. And technically that would usually be a big decimal or something. I'm just going to use an int for simplicity. And the other events and commands actually look a lot alike. So let's also make a redeem command. Let's make an issued event. So events are past tense because they represent stuff that already has happened. So now we're done. Now with the commands, they always are intended for some kind of aggregate. And I'm going to need to tell Axon that which field in those commands actually identify the aggregate that the command should be executed against. I'm going to do that with the target aggregate identifier annotation. So I'm going to put it here and there. So now we have defined our command API. Now let's implement the gift card aggregate itself. I'm going to tell Axon that this is an aggregate. I need a noargs constructor there, and I want to do some logging. And I'm going to store the identifier, of course, like this. So now I can start writing the actual handlers for my commands. So issuing is actually issuing a gift card means constructing a new aggregate. So the command handler would also be a constructor on the Java level. So let's do it like this. So I have a constructor gift card that takes an issue command. Now what I should do here on the command side of my event sourced aggregate is validation. I need to make the decision whether or not I will accept that command. Now one obvious thing here is that the amount in the command should be positive. Otherwise it doesn't make any sense. So I'm going to throw an exception if it's not positive. Like this. So there's not much else to validate. So let's apply an event. Like this. There we are. Now the other command is redeem. Redeem is against an existing gift card. So I don't have a constructor but a regular method like this. I would have the same check that we have here, but then with a redeemed event resulting. But there's one obvious other business rule I need to enforce. You cannot redeem a bigger amount than is still available on the gift card. So I need to check that if the command is actually larger than the remaining value, I'm going to throw another illegal argument exception. Like this. Now, of course, I don't know the remaining value here. So that means that I'm going to have to keep that as state in my aggregate so I can validate against it. So what you see here, the command handlers make decisions. They don't change the state. Because we're using event sourcing, the only way that state can change is through an applied event and through the event handlers for those events. So let's write those. I'm going to write an event sourcing handler for my issued event, like this. This is the first time that we encounter an event for this aggregate, so I'm going to need to set the identifier, and I'm going to need to initialize that remaining value to the amount that we have there. I'm going to need to have an event sourcing handler for my redeemed event as well, like this. And here I'm going to adjust the remaining value, of course. So now to make this a little bit transparent, let's add some logging here. Handling like this. Let's do that here as well. And here, let's call this applying. It's a little bit more clear. So now we have implemented our aggregates. Let's give this a test run. I'm gonna create a small client layer. Let's call my object that's going to execute some tests my test runner. Gonna make this a command line runner. So here I can write some code to execute. If I tell Spring this is a component, I'm going to use Axon's command gateway to send those commands. And I'm going to let Spring inject that thing. So now we're all set up. Also add some logging here. Let's generate an identifier. This. Now we can send an issue command. Like this. Command gateway.send and wait. New issue commands for say ID and 100. So I'm gonna issue a gift card for 100. Let's redeem as well. Say first for 40, and then once again for 30. Now let's run this and watch the logging. So something is going wrong. What's going wrong? No connection to Axon Server available. Is that true? We do have Axon Server here. That's not our port. That's the Postgres port. This is the Axon Server port. Let's run again. What's happening here? Invalid sequence number. Why is that? Let me just have a look at my aggregates. Issued event, redeemed events. All looks fine. This is random. Here I'm actually sending 3 issue commands for the same ID, and it's complaining that this thing already exists. I need to make a redeem command here, of course. Now it's fine. So here you see what happens. Once an issue command is sent, it's handled, it applies an issued event. And the second redeem command will actually lead to reading the aggregate in an event-sourced way. So we apply the previous issued event, then we process the command. For the second redeem event, we apply the issued event, the first redeemed event, then we process the command, which leads to another event. That's event sourcing in action. So our event source command side works now. Let's quickly write a query side as well. Create a new package called query, and we're going to create a summary of gift cards. So let's call that gift card summary, and we're going to store that using JPA. We of course need to have the identifier there. Make this a data object with a no-args constructor and all-args constructor. Let's store the remaining value, and maybe also the initial value. We're going to define an object to send those queries, so let's call that a gift card summary query, where we're actually saying to our model, please give us the summary of a gift card with a given ID like this. So let's implement a projector that will create a model and answer those queries. Call that a summary projector. Gonna make that a Spring component. And this thing is going to depend on JPA, so I'm gonna need an entity manager there. And I'm going to need to write event handlers for those two events that I have, like this. And similarly for my redeemed events. So with an issue, I'm going to need to persist a new summary using the ID and the amount as both the initial and the remaining balance. When redeeming, I need to find my gift card summary, of course, based on the ID in the event. And then I'm going to need to adjust the balance. Gift card summary. The remaining value would be the remaining value minus the amount in the event. Let's put some logging here as well. And to actually get those results, I'm going to need to write a query handler that's going to return a gift card summary whenever it gets a gift card summary query, which is very similar to what we have here, of course, but then using the query idea. So now I have my read model. Let's use it from my test runner. So I'm going to have the query gateway here as well. I'm gonna log querying. Now I'm actually gonna have to wait here because we have eventual consistency. So if I just go through with this, then probably the read model wouldn't be updated yet. So let's do it like this. I'm gonna find a gift card summary by taking the query gateway, sending a query, which is the gift card summary query, using the ID that we have. I'm going to tell the query gateway, then we're going to expect a single gift card summary. As a result of that, I'm going to join that. Summary queried would be like this. So let's give this a run. You might notice that all we have done now is still very monolithic. We haven't written any microservice yet. That's actually going to happen in the next 5 minutes or so after this works. You will be amazed at how easy that is using Axon. There we go. Now see at the end of my test run we're querying. The summary that we're getting is a gift card with the initial value of 100 and the remaining value of 30, which is of course because we started with 100 and then once redeemed 40 and once 30. So all of this works. Still very monolithic. Let's split it up now. I'm going to use Spring profiles to do that, so I can start different parts of my application without actually having them in separate projects. So my test runner is going to be in a client profile. I'm going to put my gift cards aggregates in a command profile. I'm going to put my projector in a query profile. Now let's configure my runs to actually do this. So this is going to be my clients. Let's copy this twice. This will be my command side. And this will be my query side. To have separate names for all of these applications, I'm going to make the Spring application name dependent on the active profiles. Like this. So now let me quickly show you the Axon Server dashboard because it's important to understand how this is going to work. The Axon Server dashboard is running on my local host 8024. Right now, of course, my application is stopped. And it would only show you the Axon server and the embedded event store where there's nothing there. That makes a lot of sense because I have no processes running. Let's change that. Let's start my command side. It's not running. Why not? Spring profiles. Set it like this. That looks better. And we see that the command application pops up in my Axon dashboard. There's currently one instance. I'm going to spin up my query side as well. And maybe another command side. It can have multiple of those. And maybe another query side. We are now in the microservices place. I can have these things run individually and I can have multiple copies on them. Of course, in this experiment, I'm running them all on my laptop because nothing now that's assuming that I do. It's all network traffic, so it could be running everywhere. And they should show up now here in the dashboard very quickly. So that's my query instance. Another command instance. And another query instance. So now let's run my client. Should show up here as well. There it is. And it can now send commands and queries to the other services. If I look at my logging, I see the logging from my test runner script here now. I don't see the detailed logging about the aggregates and the query model because that takes place in different processes. So I would probably see that here for the command side and one of those others for the query side. So I'm really in a microservices situation now. And that didn't require any changes to the code. I only just splitted the code by using those profiles. That's it. The reason it didn't take any effort was that all communication is being mediated through the buses and through the gateways, which are just facades on those buses. That's the concept of location transparency in action. It doesn't matter if I'm creating a monolith with Axon or a distributed system. Because of the location transparency and the key principles that we discussed, you will always be able to very quickly go to a microservices system as soon as you run that. With Axon Server, you also get great insight into what's happening here. I can look into these applications, see where they're running, which commands they can handle. I can look at counters of commands, see here that all my commands were handled on the single node, which is actually a good thing. I can see which queries have taken place. So I have a very transparent, easy to manage microservices system here using Axon. That's the demo I wanted to share on the live coding. So now let's take some time for questions.
Thank you.